The immortal sweetness, why honey never spoils, science explained. Welcome to FactSpark. Today we're diving deep into one of nature's most incredible mysteries. Imagine discovering food thousands of years old, still perfectly edible. Sounds like something out of a fantasy novel, right? But for honey, it's a scientific reality. This golden elixir, a gift from nature, holds a secret to eternal freshness that defies our understanding of food preservation. Archaeologists have unearthed pots of honey in ancient Egyptian tombs, incredibly, still edible after more than 3,000 years. This wasn't just a coincidence. Honey was so revered it was buried with pharaohs like King Tut for their afterlife journey. Even older honey, dating back 5,500 years, was found in Georgia, preserving wild berries in a Bronze Age burial site. These discoveries are powerful testaments to honey's unparalleled longevity, setting the stage for us to explore the profound scientific mechanisms behind this natural marvel. So, what's the first secret? It's honey's incredibly low water content. Honey is about 80% sugar and typically less than 18% water. But it's not just the amount of water, it's the availability of that water to microorganisms, a measure scientists call water activity. Honey has an extremely low water activity, ranging from 0.5 to 0.65. To put that in perspective, most bacteria and fungi need a water activity of at least 0.75 to grow. This high sugar concentration creates a powerful osmotic pressure, literally drawing water out of any microbial cells that dare to enter, dehydrating them and stopping their growth and reproduction. This fundamental property ensures that the water within honey is effectively locked up, making it an uninhabitable environment for spoilage organisms. This also explains why honey is hygroscopic. It readily absorbs moisture from its surroundings. If left unsealed, it can absorb enough water to compromise this protective barrier, risking fermentation. The second pillar is honey's natural acidity. With a pH typically between 3.4 and 6.1, averaging around 3.9, honey is quite acidic, similar to lemon juice. This acidity primarily comes from organic acids, like gluconic acid, formed during nectar ripening. Most spoilage microorganisms prefer neutral environments, so honey's acidic nature creates a hostile territory, hindering the growth of many harmful bacteria like E. coli and Salmonella. While acidity is a significant contributor to honey's antimicrobial properties, its effectiveness is amplified when combined with other factors. This acidic environment also plays a role in honey's historical and modern medicinal uses, such as promoting wound healing by reducing enzymatic activity and stimulating cellular repair. Our third secret lies with the bees themselves. During honey production, bees secrete an enzyme called glucose oxidase into the nectar. This remarkable enzyme converts glucose into gluconic acid and, crucially, a small amount of hydrogen peroxide. Hydrogen peroxide is a well-known antiseptic and disinfectant, acting as a natural preservative that further suppresses microbial growth in honey. Now here's a fascinating detail. This glucose oxidase enzyme is largely inactive in concentrated honey due to its low pH. However, when honey is diluted, for example, when it absorbs moisture or is applied to a wound, the enzyme becomes active, releasing a burst of hydrogen peroxide. This means that while the enzyme contributes to honey's overall antimicrobial profile, its hydrogen peroxide-producing action is particularly potent in applications where honey is diluted, such as in wound care, rather than being the primary spoilage inhibitor in the jar. This sophisticated multi-layer defense system adapts to different contexts. Beyond these three main pillars, honey boasts other protective elements. It contains various beneficial compounds like polyphenols, flavonoids, and even methylglyoxal (MgO), particularly in varieties like Manuka honey. These compounds add to its antimicrobial qualities. Furthermore, honey's thick, dense nature prevents oxygen from easily dissolving into it. Since many spoilage microbes are aerobic and require oxygen, this scarcity further inhibits their survival. It's important to note that honey isn't sterile. It contains diverse microbial communities, but its unique properties prevent these organisms from multiplying and causing spoilage. If you've ever seen your honey turn cloudy or grainy, you might have thought it's gone bad. This is one of the most common misconceptions. That process is called crystallization, and it's completely natural. Honey is a supersaturated sugar solution, meaning it contains more sugar than the water can naturally hold. Over time, the glucose separates and forms tiny crystals. Factors like the ratio of glucose to fructose, temperature, ideally around 14 degrees Celsius, and even the presence of pollen or propolis can influence how quickly it crystallizes. In fact, Crystallization is often a sign that you have real, raw, high-quality honey. To restore it to its liquid state, simply place the jar in a bowl of warm water. Never microwave or boil it, as high heat can destroy its beneficial properties. This natural transformation is a sign of authenticity, not deterioration. While honey's natural properties are incredible, its longevity does depend on proper storage. If left unsealed, honey can absorb moisture from the air, increasing its water content beyond the safe 18% threshold and risking fermentation or mold growth. Always store honey in a tightly sealed container at room temperature. Refrigeration isn't necessary and can actually speed up crystallization. Also, always use clean, dry utensils to prevent contamination. It's crucial to understand that while honey doesn't spoil in the traditional sense, it can degrade in quality over time, losing some aroma or flavor if not stored optimally. Finally, a very important safety note: honey can contain Clostridium botulinum spores. While harmless to most adults and older children, these spores can cause infant botulism in babies under 1 year old due to their underdeveloped digestive systems. Therefore, honey should never be given to infants. This distinction between natural changes, quality degradation, and specific safety concerns provides a comprehensive understanding. So, honey's remarkable ability to last indefinitely is a testament to nature's ingenious chemistry, a powerful combination of low water activity, high acidity, and the clever enzymatic work of bees. It's a true natural wonder, a sweet legacy from ancient times to our modern tables. If you found this sweet science fascinating, hit that like button and share this video with a friend. Subscribe for more amazing facts and deep dives into the science of everyday wonders. What other immortal foods or natural secrets should we explore next? Let us know in the comments below.